Hello students, welcome to JEE English, Unacademy, India's leading and largest JEE test preparation platform. And students, today we are going to explore a very interesting part of capacitor. Today we are going to discuss charging and discharging of capacitor. Of course, like this topic is, like a very independent topic of, it's not dependent upon other topics on capacitor. But anyway, that being said, today we are going to explore some tricky and interesting concepts and as well as discuss previous year JEE Mains and JEE Advanced questions in this session. So stay tuned and also share this video, guys, and call your friends on board for this lecture. And students who know me well and good, if not, I'm Muralidharan GopalKrishnan. I completed my MS in Electrical Engineering from University of Colorado Boulder, and I'm also an IITian who completed my BTech from IIT Guwahati. I have 4+ years of experience preparing students for IIT, JEE and other competitive exams, and I have filed 25 patent applications in India and abroad. And students, make sure you're already on the Telegram channel of JEE English, because you'll get all the updates on time, be it any special sessions or any daily sessions, any changes in schedule, or like anything that is happening on Unacademy learning app by the JEE English team. And guys, we have the best in class team, so get onto this channel to get all the updates in time. We have like IITians and like rank holders, IIT rank holders. Not only that, we also have previous head of institutions and HODs of popular coaching institutes. So make sure you're getting onto this channel. Click onto this link available in the description box below. Else, if you already have the Telegram app, you need to have the Telegram app even for clicking onto the link and to getting onto the channel. So first of all, download the Telegram app, and if you are already on the Telegram app, you can just search JEE_English and you will find us, guys, and you will get all the updates in time. And that being said, students, we completed a special class on color coding of resistors and also one on like electrical instrumentation in one shot. And these are like very important topics for your JEE Mains syllabus. And like in JEE Mains 2019, that is last year JEE Mains, around the same year, you had anywhere around 5 questions combined on this very small and easy topic. So complete this topic as early as possible. Don't miss it out. And similarly, the electrical instrumentation in one shot, which are like the very important, like very easy. And not only that, you don't need to have any prerequisites to complete these topics, but you need to at least go through these topics once. They will hardly take you a few hours to complete, but anyway, you will get 1 or 2 or 3 questions from color coding of resistors and electrical instrumentations. Make sure you complete all of these topics in time, guys. And it's available on the Unacademy learning app, and you can search this lecture over there. And that being said, students, to get notifications on any such live classes happening every day, you need to download Unacademy learning app. All you need to do is search Unacademy in the search bar of your Google Play Store and App Store, and the first result that you would find is Unacademy learning app. And that is all you need to do, guys. And then you will click on that install button, and you will get access to awesome lectures, live updates. So if you have the app, you'll get access to live updates. Hi. And that being said, guys, so if you are looking for something for your JEE preparation, we have an awesome platform for your JEE preparation, which comes with live quizzes, live test series, and not only that, you get your all your lectures in a very systematic manner. Of course, you get lectures for free of cost on JEE English. But that being said, guys, what about your test preparation? What about your time test? So we provide you, like an awesome, access to an awesome platform for your JEE preparation, which comes with all the live quizzes, live test series, and you can learn from your favorite teacher. And not only that, guys, it's a single subscription and unlimited access. So these many perks and benefits. And how do you choose it? All you need to do is click on that extension bar and then choose IIT JEE as your goal. Be sure to choose IIT JEE as your goal. It's easy given that you have access to the right kind of tools. And that being said, all you need to do is then click on that get subscription. And guys, not only that, Unacademy subscription platform comes with the state-of-the-art technology that puts you in the real-time environment, like what you can expect in your exam. So that being said, guys, how do you avail the subscription, and what is the right kind of subscription for you? Let's say you're in 11th class or 9th class and 10th class. It's best that you go with a 24-month subscription, because it's a 2-year long journey. So you want to choose the 24-month subscription, and the prices are low now, students, so choose and avail it early. And you know what, you can apply Murli live coupon. So right now the prices are anywhere around 1,500 per month, but let me tell you something. If you apply this Murli live coupon, you will get a 10% additional discount on your purchase. So make sure you apply this coupon. You do not forget to apply the coupon. And students, make sure you purchase it early within the next 48 hours. And you can also avail like a 12-month subscription if you are in long term or dropout, which may be an like an ideal subscription for you if you have only 1 year left for your preparation. I mean, the cost difference is not going to be too much, but anyway, if you have only 1 year subscription, you can get it. And 24-month subscription is much suited for 11th class students, 9th class students, 10th class students, or anyone who has 2 years long journey. Make sure you get the 2-year subscription, because you don't want to spend extra bucks on your subscription. And that being said, guys, you can still get a 10% discount on this. So it's pretty economical. It's more economical than what you can expect. And not only that, guys, you get access to the best in class educators across the nation. And moreover, we have popular authors like DC Pandey sir, legends in physics on this single platform. And let me be frank with you guys, you wouldn't get access to one such like quality education anywhere. And that being said, guys, the price hike is real, and the price hike is going to come up in 2 days. So 2 days are left for your Unacademy subscription hike. So make sure you get it on time. And make sure you are going to get the subscription within these 2 days, because from 10th of September the hike is real, guys. So make sure you get the subscription on time. Enroll now, students. And what is the cost now after you apply Murli live coupon? The cost now is anywhere around 32,400 for your 2-year subscription. And what about after or from 10th of September? Actually, it's from 10th of September. So make sure you get it before 10th of September. And if you apply Murli live coupon, even after your 10% discount, you're going to get it for 50,400, which is going to be the best price. Of course, it's a good price, but make sure you get early so that you can save anywhere around 18,000 rupees, which is a considerably significant amount, guys. So make sure you avail it early. Make sure you get it before 10th of September. Hurry up, students, hurry up. Apply Murli live coupon and avail your subscription before 10th of September. And so that being said, let's get into the lecture. Only 2 more days, so make sure you get it early, guys. And so make sure you also share this channel, because you are getting all the quality content for your JEE preparation from your basics until advanced for free of cost. So make sure you share this channel so that someone in need may get access to an awesome channel. And not only that, guys, JEE English is the first channel across the nation where you get all your lectures for your JEE preparation from basics until advanced without any hassle. From your home you can learn everything. It's a YouTube channel, of course, you know that. So share this channel, and we have like the best educators on the team. So do share this channel and do like the video. And guys, do remember, the key to success is not to focus on the obstacles, but on your target, dreams and goals. Make sure you are staying focused throughout your journey, and start dreaming about getting into IITs and NITs. It's very important that you have your dream and target set in your mind, so that you are not deviated here and there. Don't get distracted by like unnecessary things. This is the time, guys. So the key to success is to not focus on the obstacles, but to focus on your targets, dreams and goals. And you keep dreaming about your goals and getting into those awesome IITs and NITs. And that being said, students, today we are going to get into the charging and discharging of capacitor. So I hope you have attended even the last lecture. If not, after the class, go and attend it. It's anyway like we are going to discuss few concepts, like do a very short revision. But anyway, do get into the depth of the topic once we complete this lecture on the charging of capacitors. So that being said, as you can see here, we are going to primarily discuss 2 things. One is this, charging of capacitors when you have, many resistors in combination. The other one is the discharging of capacitors. So that being said, students, we have already discussed charging of capacitors. You can go back to the lecture later. It's an independent topic. Even discharging of capacitor, we'll derive it. So that being said, if you remember, Q is equal to Q naught 1 minus minus T by tau is the equation that you would get, something that you want to remember because it's necessary for your exams. So when does this happen? This happens before the steady state. This is something that you can expect before the steady state, but let me tell you something, until 5 tau, 6 tau, you don't reach the steady state. Okay, so this is before steady state, and you don't reach that steady state until that 5 tau and 6 tau. That's going to be like not a lot of time, but anyway, you can't really attain that that ideal steady state. So once you have closed this switch, then what is going to happen, the current is going to flow through it. Initially this capacitor will act like a short circuit, guys. So these are some important concepts. So there was a JEE advanced question, literally a cakewalk for you, just based on this thing, that a capacitor acts like a short circuit at t is equal to 0. So over the time, the charge builds up on the capacitor when you are charging it using some external EMF source. So this is going to be an external EMF source. Then you are going to start charging it, and once you have closed the switch, the charging will begin and the charge buildup will take place, and eventually it will attain the steady state, near about steady state after 5 tau and 6 tau. And what is the Q0 over here? It's going to be the entire potential that would have been dropped across the capacitor if there wasn't any resistor. So it's going to be seen to be. And what about your tau? Tau is the time constant. What is the significance of tau in charging of capacitors? So what happens at tau, students? So at tau, your capacitor will accumulate 67% of the potential across it, or 67% of the charges while charging the capacitor. So yes, it's 63%. I'm sorry, I need to correct myself. It's 63.2%. So do correct it. So it's going to be not 67 but 63.2%. So make sure, and 1 by tau is 0.37. So this is going to be obviously. So there are a few things that you need to remember. One is conversion of log to the base e, that is natural logarithm conversion, to your to your log base 10. And the other thing is what happens at each tau. So this can be written this way as well, that it was Q0, you simply multiply it with divided by C, you will get the potential that is going to build across the capacitor. Hi Sumant, hi. Very good evening, students. Stay focused on the lecture and share this lecture on your social media, so that you have your friends and also other students who need this lecture on time. And that being said, what is happening at 1 tau, you are going to accumulate anywhere around 63.2% of charges or the potential across the capacitor. Then it goes to 86.5, 95 at 3 tau, and at 5 tau it's like when it is t tends to infinite is when you will expect the entire potential to drop across the capacitor. It does not happen, but at 5 tau, near about 99 point some percentage is going to be dropping across the capacitor, or the capacitor is going to develop 99% of the potential. Okay, that depending upon the configuration, we'll understand what do I mean by the configuration as we move forward into this lecture. And at 4 tau, it's anywhere around 98.2%. So that being said, what would be the current graph be looking like? So if you remember, in charging, the charge was increasing while the current is decreasing, guys. So the current is decreasing and the charge is increasing. Why is that happening? Because your capacitor is getting charged, it develops potential in the opposite way to your flow of the current. So that means there is going to be some negative potential across the during the flow of that current. And so that would be like decreasing current. And when we are talking about current, what is the equation? I is equal to I naught minus T by tau. What is I naught, students? I naught is nothing but your V source by the resistance or the resistor across the circuit. And at tau, what is happening to the current? The current drops to 37% when the charge builds up to 63%. The current drops to 37%. And the same thing is true at 5 tau, it attains the steady state. That means at steady state, like at 6 tau and 5 tau, that is the near about assumption that we have, that the current becomes nearly zero. So at this time, So yes guys, so that being said, let's get into the topic of the day, that is going to be discharging of capacitor. So we did this topic, you understood that equations. Anyway, if you want to have a look at the derivation and few problems around them, you can visit the earlier lecture, but let's now focus on discharging of capacitor. This is going to be an independent topic. So let's assume you have charged a capacitor to potential V, and it has a charge accumulated on its plates. One is going to be plus Q naught and the other is going to be minus Q naught. Okay, so Q naught I'm just saying because it's the initial charge I'm assuming. So and what happens once you close the switch? Once you close the switch, some current will start flowing through it. And how would this current behave? The current would flow until these charges, actually it's going to be the electrons. The electrons are going to flow from here, and and ultimately there was a charge polarization, and this charge polarization, this current will flow until the charge polarization is going to disappear. Okay, so once you have closed the switch, the capacitor will begin discharging. So this process is known as discharging. There you are charging the capacitor, you are building some potential across it. Now you are discharging the capacitor and losing the potential across the capacitor. So you're losing basically the energy stored across the capacitor and the charge polarization as well. And what happens? The current will start flowing, the electrons will flow in the opposite direction, and this charge polarization will disappear, and this process will continue until it loses all this charge plus Q and minus Q across it. So it will eventually become some zero. Okay, and the potential would also become zero. And what about the current? The current will also become zero, because here the energy source is capacitors, not a battery, right? So eventually at t tends to infinity, what is happening? Q is equal to, it's not exactly Q is equal to V is equal to, but Q is equal to 0, V is equal to 0, and I is equal to 0 is what you would be observing, right? And let's derive the equation. So we know that at time t is equal to 0, what is happening? At time t is equal to 0, the charge was something like Q naught, and if I say the potential across the capacitor is something like V, right? So in that case you would have Q is equal to CV, so it's going to be C into V, right? Or C into V naught, let's keep it for V naught as now. So that is the initial potential across the capacitor. And now once you have closed the switch, okay, this is the time is equal to t is equal to 0 until the switch was open. Until the switch is open, it's like it's an isolated capacitor circuit. And once you have closed this switch, it can, if there wasn't any resistor, what is going to happen? It will immediately discharge, right? It will immediately discharge. Okay, and it will immediately discharge, and you would see that it will come down to 0 indefinitely. But when, let's say, when we are not doing this thing, we have a resistor, it will take significant amount of time to discharge the entire charges. So at t tends to infinity, we will say that Q becomes 0. Until then, it will have some charge across it. And also, let's write down what is the potential across the capacitor. VC initially at time t is equal to 0 is going to be V naught, whereas at some like at time t is equal to infinity, so we are discussing two different cases. So yes, and this would be like 0 again, right? So what is happening? Let's analyze how this capacitor is discharging. What is the function of this? Like the way the capacitor is discharging in terms of function of time. So I'm saying just that at time t is equal to t. You can take anything like t1, t2, just we need to have an equation. I'm going to keep it as time t is equal to t, some q is equal to q. Okay, so let's derive the equation. So what is happening in this case? There is some current flow, and what is this current happen? What is happening to the current? The current is decreasing, right? The current is decreasing. And how is the current behaving? Let's forget that we are just talking about anything like capacitor or something. We generally write it down as dq by dt. And in this case, what is the dq by dt? Dq by dt is nothing but your current should be your potential by the value of the resistance, the potential at that time. Okay, so potential at that time is going to be V, okay, which is going to be equal to Q by C, isn't it? Right? It's going to be basically V by R, given that there is a resistor R in the circuit, and that is going to be Q by RC. But what is happening to the current? The current is actually decreasing with time because the charges are depleting. Okay, the charges are depleting, the capacitor is discharging, so you're going to add a negative sign. Okay, minus dq by dt, and all you need to do is take up these two equations and solve it to get the equation, right? So it's going to be minus dq by q is equal to t by dt by rc. dt by rc you are going to integrate on the both sides, right? So let's move on to the next page and let's understand what is happening. So dq, so this is rather very easy, discharging of capacitor, the entire derivation. To understand the process, it's not going to take you much time because there is only two electrical components involved in this. And whereas in our earlier case there were a lot of like while we are talking about charging of capacitor, there were like three elements. One was battery, and then the other one was the capacitor itself, and there was also a resistor. Now in this case we only have two electrical components, which makes our life really easy. So that's going to be dq, and this is nothing but dt by rc, I guess. So you're going to integrate on both sides. Here you are going to integrate from some q naught to some q, okay, and that is going to be from time t 0 to t. So whatever you're going to get, I'm basically going to carry this negative sign on the other side and integrate it and say that this is nothing but t by rc, which has to be minus t by rc, which has to be integrated from 0 to t. All right, so you would finally get it as only minus t by rc, and on the side you are going to get it as something like log q, right? And this is going to be from q naught to q, right? And what is this equation going to give you? It's going to yield something like log q minus log q naught is equal to minus t by rc, right? So what about this? This can be written as log q by q naught is equal to minus t by rc, right? So you raise on both sides with an exponential. So we had this equation log q by q naught is equal to minus t by rc, right? You raise exponential on both sides, you would get it as q is equal to q naught e to the power minus t by rc. Okay, so this is the equation that we are getting, and let's just draw a box around it. So are we really getting the right kind of equation? Let's verify it. At t is equal to 0, we should be getting q is equal to q naught, right? Q is equal to q naught e to the power 0, like it's going to be 1, so we are getting q is equal to q naught. And t tends to infinity, what should we get? We'd get something like q is equal to q naught divided by some infinite quantity, which is going to be 0. Yes, we are getting everything. And how do you derive the potential? Potential is going to be basically you're going to divide by capacitance on both sides. You divide it by c on both sides. I can say it is nothing but v is equal to q by c is equal to q naught by c into e to the power minus t by rc, which is equal to, I'm just calling it for now as v naught, which was the initial potential. If I'm assuming across this capacitor the initial potential was v naught, I'm going to write it down as v naught e to the power t by rc. That's it. So that is all we need to know. Yes, that is all we need to know. So what are you observing in this? Now at this t is equal to tau, this is still the tau, RC is the time constant. So the charge is becoming 37%. Right, while charging, you had 63% across the capacitors once it has reached t is equal to tau. And this tau is a very small quantity, you need not worry about it. So we'd get a equation like this, and so this should be, this is not Q is equal to CV. So just a moment. Okay, Q is equal to CV. Okay, that is correct. Q is equal to CV, Q by C. Yes, that is correct anyway. So yes, you can write it down as CV, assuming this is CV naught. You can write it down that way as well, and you can write it down as Q naught. And what is Q naught? Q naught, if only potential is given to you, this V naught is given to you, that is going to be C into V naught. That is for a given potential difference you have initially charged it, then like an battery of EMF V naught, you would get the charges Q naught is equal to C V naught. Right, and again we are going to call this RC as tau, which is nothing but time constant. This is a very important terminology, guys. The problems are mostly going to be around your time constant. Working around and playing around the time constant is the most important thing while we are dealing with charging and discharging of capacitor. Okay, and as we spoke, at t is equal to tau, what is happening? You only have 37% of the charge remaining on the capacitor. At t is equal to tau, you only have the 37% or 0.37, times the Q naught, that initial charge, right? This is the initial charge left on the capacitor. That also is the same for the potential across the capacitor. Right? That is it, guys. That is all about your discharging, and we are going to have a look at a graph. So this graph says the same thing, and you're observing at near about 5 tau, 6 tau, what is happening? The charge is totally depleted. I mean the Q is tending to 0, it's near 0, or it's approximately 0. That's what you can indicate it as. 0 coulombs is what would appear across the capacitor. So it's like the charge is decreasing now along with time. So this is a graph of potential, but what is Q? Q is equal to CV. So you can basically see is constant, so the potential is also decreasing, right? So this is what is happening at t is equal to tau. You only have 37% of the remaining charges or the potential across the capacitor. Okay, 63% of the charges are lost. There you had a gain of 63% of charges across the capacitor. Right, so we have this equation. All we need to do is just differentiate this equation to understand the current. The current is going to have a very similar, pretty much the same kind of equation, that is going to be minus dq by dt. Since the current is decreasing, I is equal to minus dq by dt is equal to, you are going to differentiate this equation, which is going to yield q naught minus q naught into q naught into minus 1 by tau, right? This is minus dq by dt, so I need to so that's going to be minus q on this side, and e to the power 1 by tau. Okay, and you're going to have this one over here, right? So that this 2 would cancel out. You would get as like q naught by tau. What is tau? Tau is, value of tau is RC, right? RC is something that you have to remember, guys. Okay, RC is time constant. Yes, Renu, hi. Yes, this would be the last chapter on capacitor. Any theoretical session, this is going to be the last one. We will have DPPs. There we will discuss different kind of model problems, but make sure you are thorough with the concept before attending the DPPs, because the DPPs, I'll try to take it step by step DPPs, but make sure you are already thorough through these things. We'll discuss different kind of model problems, especially today's topic, right, students? So I don't know if we have any, especially the next half of the session, we might not have any DPPs around them as such. So for target 2021, the next chapter is going to be magnetism, guys. Okay, we'll start with magnetism. And what is this? Q naught by RC is equal to e to the power t by tau, which is nothing but V naught Q naught by C is V naught e to the power t by tau. That's it. So I'm going to just denote this as I naught into e to the power t by tau. So yes, it's going to be basically E naught. So what is I naught? I naught is nothing but V naught by R, which is nothing but Q naught by C by Q naught by RC, or Q naught by C, which is nothing but Q naught by tau. Right, and you are going to have a very similar equation. There is no much difference between the equation and what is happening at time t is equal to tau. The current is becoming 37% of the initial current. Right, current is becoming 37% of the initial current, and at 6 tau almost it's 0. So you lose 99% of the charges. You also lose the 99% of the current intensity. Okay, that is it. So let's get started on some awesome previous year JEE Mains problems. So the problems are going to be super simple. All you need to do is you should have understood that concept. You should have memorized some of those concepts, and also the conversion of log natural log to log base 10, which is going to be conversion factor is going to be 2.303. And apart from that, yes, that is it. And also the logic, guys. I'll tell you why the logic, because the second half of the session is all about logic. So this is still not memory based thing, very well now. We just derived the equations. So what is this question saying? Let a capacitor of capacitance C is discharging through a resistor R. Yeah, students, so start answering the question and what it should be. Suppose time t1 is taken for the energy stored in the capacitor to reduce to half, and you not get highlighted things like this in your exam, but I will just highlighted it for you. So t2 is the time taken for the charge to reduce to 1/4 of its initial value. Right, so two things are given to you: time t1 where the energy stored becomes half, and time t2 where your charge becomes 1/4. And don't move with so much pressure in your exam, because this is a very easy question. You can do it literally. If you are not going to explain it to anyone, just write down the equations and move fast. You'll understand the answer very quickly, but at the same time don't just mark right away 1 or 2 just from your assumption. So let's get started on to this. So at time t1, what is happening at time t1? At time t1, what is happening? Energy becomes half. E is equal to E naught by 2. Right? It's E. It's actually E. It looks like epsilon. So what is the equation for energy? E is equal to half CV square. Right? So let's do a thing. Let's keep it as E itself, because it's not EMF, it's energy, right? Okay, so it's half CV square. So if it is half CV square, so let's assume that initial charge on the capacitor was Q naught. Q initial was Q naught, and it's an isolated capacitor case, so you're going to write it down as Q square by 2C, right? So let's analyze what is happening to the charge. This Q, let's keep it as like Q1 in this case, because it is T1. Okay, Get into this habit of writing it down as Q1. Here I'm not writing it down directly as Q1, but you should be writing it down as Q1. So we need to analyze what is happening to the charge. So the initial charge was Q0. Now let's say the energy has become half. Okay, the energy has become half means what was the initial energy in that case? E initial or something like Q0 square by 2C. Right? So let's analyze at let's derive this Q1 in terms of Q0. Half of it, E is equal to E0 by 2 implies your Q1 square by 2C is equal to half of Q0 square by 2C. 2C would get cancelled. Okay, there would be 2, sorry. This 2 would be there. 2C would get cancelled, and your Q is finally Q1 is Q0 under root 2. That's it. So you got the value of Q0, and we need to basically throw this equation into our the charge equation, discharging charge equation, which is nothing but Q is equal to Q0 e to the power t by tau. Okay, let's analyze that. So what is the time t1 is what we have to find out. We know that Q1 is equal to Q0 e to the power t by tau, and how much is Q1? Q1 is nothing but Q0 under root 2. Q0 under root 2 is equal to Q0 e to the power t by tau, right? So e to the power t by tau is equal to 1 by root 2, and in questions like this you don't want to oversimplify the problem. All you need to do is apply log on both sides, and you'll eventually arrive to this. T is equal to, so it's 1 by root 2, that can be written as 1 by root 2. So we are analyzing T1, right? Solve T1. Okay. So you have T1 everywhere. Make sure it's not necessary, but you can quickly do this thing. No, just we are doing it for the first time, so we are going to do this. So T1 is equal to some tau minus tau into log, and this can be log 1 by root 2, which can be written as hi Krunal, hi. So yes, we just started on some previous year JEE Mains problem. So what is this? This is going to be minus, because this can be written as root 2 to the power minus 1. So let's do a thing. So this is root 2, right? 1 by root 2. This can be written as students, do comment if you're not getting these things, because then we may need to do a basic math class, but I believe most of you do understand this, and this can be directly written as minus 1 by 2. Okay, right? So your T1 is nothing but tau. Minus would become plus, and this will be log. I'm going to write root 2 as 2 to the power 1 by 2, which is going to be tau by 2 log 2. That's it. Okay, so what was the value of your T1? Just write it down. T1 is equal to 1 by 2 natural logarithm of 2. So this is your value of T1, and I hope this is visible. Yes. So that being said, what about your T2? T2 is pretty simple, but I guess we don't have space. So I'm going to erase this part. So let's move on and, let's move on to the earlier one and erase it. We understood this part, I believe. Okay. If it is too slow, what you can do is you can speed it up. If it is too fast, you can just slow it down. You have options for that. So you may do it as you like. And yeah, why am I doing this? So yes. So that being said, so what is your T2? T2 is when your charge reduces to 1/4. So we can directly write down the equation. I'm just directly writing down that so let's say Q2 is when initial charges become 1/4, right? Q0 by 4 is equal to Q0. So this is basically saying e to the power minus t by tau, right? Pretty simple. Yes, that's not available in the live. That is true. Yes. Anyway, we are moving really slow, guys. So I believe I'm moving slow. If it is too fast, you can let me know. So we are writing down each and everything Q0, and that way, this is e to the power T2. This is going to T2. So what is your e to the power minus T2 by tau? That is going to be 1/4. And so you apply log on both sides. So if you apply log on both sides, this is going to be minus T2 by tau. And we just did what happens to log? Log 4 to the power minus 1. Okay, that is nothing but, so yes, okay, fine. For now, I'll write it down as minus ln 4. And what is 4? 4 is 2 square minus log 2 square. That is going to be T2 by tau. So I'm cancelling the negative signs on both sides. Log of 2. Can we write it down? Yes, we can. And what is the value of your T2? T2 is 2 log 2. And what about your T1? Okay. So your T1 is 1/2 log 2. You divide both, what do you get? 1/4. Right? T1 by T2 basically. So log 2 common, and you have something like 1/2 into log 2 into 1 divided by 2 log 2. You cancel out log 2, it's going to be 1/4. Really simple. Couldn't be easier. Alright, so yes, you can expect these kind of questions in your JEE Mains, and we'll also see what other kind of questions can you expect. So one of the things I've told you is near about 5 tau, the capacitors be charging or discharging, it will attain that steady state. But this question is not about it, but do remember that point as well. You don't want to spend your lot of time on just deriving all your equations. Even in that case, you should have understood, it's going to be log 2. You should have directly wrote it down as q by under root 2, but you'll get that with practice, students. If you're not getting it now, don't worry about it. You will get everything with practice. Right? So in this question, hi Roshan, very good evening, good evening. So in this question, they are asking you, so the figure shows an experimental plot of discharging of capacitor. Students, can you guess this answer? I'm good, Roshan, how are you? It's a simple one, right? So they are saying, there is, like an experimental plot for discharging of capacitor. The time constant T of the circuit lies in between how much? Okay, let's zoom in the graph. It looks something like this. So what happens at T is the time constant is what they will mention. Okay, Time constant means T is equal to tau. So Roshan, what's the answer? Like how do you do this? What happens at T is equal to tau for discharging? For discharging case, your Q becomes 0.37 Q naught, and similarly your V becomes 0.37. No worries. So yes, so V naught is going to be the maximum potential or the initial potential across the capacitor, which is 25 volts in this case, right? So we need to find out what is when it becomes V is equal to 0.37 of 25 volts, right? That is it, that's all we need to do. So 37, that's going to be 175 plus 75. Let's do that. Yes, 25 into 37, that's going to be 175 and 75, that's going to yield 92.5 or 9.25, sorry, okay, 9.25. So that's going to be 9.25 volts. So where do you have 9.25 volts, students? Between this range, so somewhere not this one exactly, you know, it's going to be let's take it up. When does this come? Somewhere over here. Okay, we don't know yet. So you already know the answer. So yes, actually it's like it should be between this, somewhere between 100 and 150 seconds. Okay, it's given as seconds. Generally your capacitor, depending upon the resistor, your time constant can vary. Your capacitor generally has milliseconds, etc. as your time constant. So it's basically answer A. Really simple cakewalk question that you could have done within like few seconds, and you could have got this marks. So basically all you had to do was all you need to know was 0.37 would give you T. You need to take 0.37 of the voltage at T is equal to tau. V is equal to 0.37 V naught is all you had to do, and you would get the approximate value. It should be between 100 and 125 seconds. That was, we got it as 9.25 volts. Right? Simple, really simple. This is the JEE Mains problem, guys. So really simple problems, but basic concepts was what is involved in this kind of questions. So yes, students, general question: a capacitor is charged to 100 volts. So I just brought this question to your notice because I noticed this question and I saw, okay, there isn't any resistor mentioned in the question. So we see this question, there isn't any resistor explicitly mentioned in the question. Okay, and they are saying it is getting discharged if there wasn't any resistor, but which is an ideal case, even your wire would have some resistance. So that way you can assume that this is a very practical question. So capacitor is charged to 100 volts and it is discharged by connecting two plates at time t is equal to 0. Now, which gives you that hint that there might be a resistance across the capacitor. So they are saying that if the potential difference across the plates drops to 1 volt at t is equal to 10 milliseconds. Right? If it was not a case of where you don't have any resistance at time t is equal to 0, so what would happen to, what is tau in that case? Your tau is like resistance is 0, so your tau is 0. So if your tau is 0, what should be the right away if you connect it, the entire charge should be discharged and the capacitor should reach the neutral neutral charge polarization state. But that didn't happen. Okay, what happened really was at 10 seconds you lost 99% of your potential. 99% of the potential. Okay, you can do it even using tau. That would be very interesting. If 99% is lost, this is near about 5 tau. That is going to be something like like tau is equal to 2 milliseconds. So anyway, near 2 milliseconds because it's 99.2 or 99.3%, I guess. So let's move into this question. They're asking you what is the potential difference across the capacitor T is equal to 20 milliseconds. But anyway, I haven't given you any option. 0.0 volts. It's all 0.5, 0.25, 0.05, 0.01 volts. Are you sure, Krunal? Did you work out the equation? So students, do remember, if you get a question like this and they have told you, the capacitor is, initially at 100 volts and it has been discharged after 10 milliseconds, it becomes 1 volt. That means it's not an ideal case where there isn't any resistance across it. They just said it is discharged by connecting the two plates, maybe through a wire or something. Okay, so there is some resistance across it. Do understand that point. This is the reason that I brought this question to your notice. So in these kind of questions you should understand, because you would have studied so many concepts. At the end moment you would not you might not get into that concept. Okay, but they are asking you what is the potential difference at T is equal to 20 milliseconds. How do you do this question? Do it again. Yes, that is correct. Yes, Krunal, very quick. Awesome. Yes, it's not going to become half, right? Let's analyze it, what it is going to be. So you're going to write Q is equal to Q naught. Instead of that, I'm going to write down as V is equal to V naught this time. Let's not do that Q by C again and again. Let's just write it down as V is equal to V naught e to the power minus T by tau. And this is going to be time 10 milliseconds, that. So I'm just keeping it as T1. And what happened? It became 1 volt. And the initial potential across it was 100 volts. Okay, let's keep it as V1, V naught is equal to 100 volts, and whereas V1 is just only 1 volts. Okay, and value of T1 is also given to you. T1 is equal to 10 milliseconds. That was really quick. Yes, awesome. So don't make these kind of silly mistakes, when it comes to exam, because it's very tempting to make silly mistakes in these kind of questions, whereas these questions are very, 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 very easy. Okay, so what is the value of your tau is what you have to derive. Just I'm doing it directly. It's going to be how much? I'm going to keep it as ln 100. Okay, it's going to be basically tau into so T1 is equal to tau into T1 is equal to, okay, so I'm calling this as T1, right? And T1 is equal to tau into ln 100. I think 1 0 disappeared from here, but anyway, so you understood it, how to do it. So what is actually your T1? T1 is 10 milliseconds. Just keep it as milliseconds for now, because let's keep it as 10 milliseconds for milliseconds as now, because our second question also is talking about milliseconds. Okay, so your tau is nothing but 10 milliseconds by ln 100. You don't have to do any further mathematical operations, especially when it comes to your exam. Don't spend your time, especially on discharging and charging of capacitors, meant to be like that, guys. Your questions are meant to be like this only. So 10 milliseconds, I'm substituting T1. Okay, so I'm substituting T1 is equal to 10 milliseconds, and then I'm getting this question, this answer. Rarely your units would play a part in your exam. So now what about your this can be quick, this can be really quick, like how Krunal did it, and let's understand how does that come. So at time T is equal to 2, I'm saying it's at time T is equal to T2 is equal to 20 milliseconds is what we have to find out. Okay, the potential is what we have to find out. We don't know V2 is equal to V naught e to the power T by tau. Okay, T2 by tau. Okay, and we know this is 100 and this is exponential minus how much is your value of tau? Tau was 10. Okay, this is 20. I'm just substituting the value of T2. I'm just substituting the value of T2 since this is in milliseconds. I'm not, worrying about the, your, it's going to be into ln 100, right? So that's going to be, so what you're going to do, you're basically going to take the square. It's all about, basic math that you have to work on this so that you get the answer right away. Yes. So sir, 12th class का exam 3rd February से start होगा. I don't know. I'm guessing so. So yes, we are back to new normal. That is what is going to happen. We are t by tau, and that is going to be e to the power. So this is exponential log. Putting it this way for now, 100 to the power minus 2. Don't forget the minus 2. There should be minus 2. But anyway, you know that the potential has to reduce. And after 10 tau, that is 5 tau, 99% is 5 tau. So we are observing something really interesting, guys. So it is again going to become 1 by 100th of our, potential at t is equal to 10 milliseconds. That's what we are going to observe in this question. Okay, once 10 milliseconds increases, we are going to observe a boom. So this you can cancel out. So that is going to be 100 divided by 100 square. How much is that? Basically 0.01 volts. Actually a tricky question, right? Just to mislead you for that moment, these kind of questions will appear. Don't get misled by simple things, right? So yes, I don't know Jay Akash, but really you can't skip. So good question from Akash. So Akash is asking that, so we haven't gone to school, and will the 11th portion be included? I don't think your 11th portion can be skipped. Okay, it will be minimized. Definitely you will have, but why 11th portion? It should be 12th, right? Okay, it will be 11th. Yeah, but maybe it will be minimized. Your syllabus will be minimized around 11th. And anyway, guys, your 11th syllabus is hardly 40% in your JEE Mains and JEE Advanced. Okay, rest 60% is your JEE, like your second year portion. So make sure you're strong with the second year portion and you come to classes regularly. That itself will boost your marks. So what are the moral of the question, guys? So one is, don't assume that if they are just saying connecting two plates at time t is equal to 0, immediately the potential would become 0. That is true, but if at all they have told you 1 volt at t is equal to 10 milliseconds, that means the capacitor is discharged. Okay, as it would discharge. And what has happened to the potential at 20 milliseconds, at 2x time? At 2x time, it has become, initially it was 1 by 100, again it had become 1 by 100. Okay, V1 1 by 100 is what it became. Small things you can remember so that you can solve your papers quite quickly. Yeah, I guess then your exam may not happen from 3rd of if your board exams are scheduled from 3rd of February, it may not clash with any of them, right? So that was easy, quite an easy question. I think this was also a previous year JEE Advanced or JEE Mains question. I'm not really sure. Okay. Anyway, take down the notes, students, because your notes might not. So this is a JEE Advanced question. This one part of it, go and solve the rest of the parts. They are very, very interesting. So this is based on some concept that we discussed earlier. Okay. So I'm asking you, what is the potential across this voltmeter as soon as the key is closed? Okay. Observe the diagram carefully, students. What should be the potential? I'll give you a bigger diagram. So try to guess it, students. Try, start working on it. There is no guessing. It's very simple, but be very careful. It's a JEE advanced question. So what should be the potential across? What will be the potential that will be measured by the voltmeter is what is being asked to you, right? It's not, they're not asking what is the potential across the voltmeter, but rather they're asking you what is going to be the potential across the voltmeter as soon as you close the key. Okay, as soon as you close the key, what is the potential? Any guesses? What should be the potential in this case? Whether it should be 0 volts, 5 volts, minus 5 volts or infinite. Little bit of, a little tricky it should be, right? It's a JEE advanced question, so expect some trickiness. You don't want to do that. Yes, absolutely correct. It is going to be, so many of us might think, capacitor. So what is happening as soon as you close the key? As soon as you close the key, t is equal to 0, not tends to 0, but t is equal to 0. That is just you have closed the key. Yes, option B, that's correct option. So what's your question? Can we switch the capacitor and resistor of the right side? No, you don't have to do that. You can't switch it, but you don't have to do that. This is rather, not a very tricky question. I mean, it's a tricky question actually. It's not, like a very confusing thing that, you don't need to do a lot of math. All you need to do is understand the basic concept. So time t is equal to 0, capacitor is a short circuit. Right, capacitor is short circuit. That's brilliant, students. That's brilliant. Really brilliant. So capacitor is short circuit. What is happening as soon as I'm closing the key? I'm going to, think about it. I mean, like probable path of current should be like this, something like this. But no, that's going to be like something like near about infinite current, not really infinite current. So you are actually measuring the potential across the battery. But so you are actually measuring, it's as if it is connected like this. Right, you hook it up this way as soon as you close the key, and this terminal you hook it up this way. If you hook it up this way and this way, what do you think will be the potential measure? But notice the polarity. The polarity is minus and plus. So actually on your voltmeter, it is not going to show you plus 5 volts, but rather minus 5 volts. Not a very fair question. It's a really unfair question unless you have dealt with, lab instruments, you're not going to know this. But yes, if you reverse the polarity, you are going to get minus 5 volts reading on, because you are connected the negative terminal to positive, the positive to negative. It is actually measuring 5 volts potential difference, but in the reverse way around. So it is actually measuring not 5 volts plus 5 volts, but rather minus 5 volts, right? Yeah, easy. So how to increase the speed of solving? How to increase the speed of solving? You solve many questions. You solve at least 50 questions a day on physics. Okay, 30 questions a day on physics. Try to solve it within 1 hour. Okay, that should be your target. Maybe we'll do some specific session on that, or we'll do some practice problems that way, where you are only you should be only targeting initial phases. It is not going to happen, students. A really good question from Krunal: how to increase the speed, like problem solving speed. So while you're solving the problem, there is this thing, right? You just started with the chapter capacitors, charging and discharging of capacitors. It's going to take some time, but over the time, make sure you're practicing that chapter entirely, or that subtopic, or that topic completely. Okay, because you want to cover one topic completely, you may get questions from anywhere. But after some time, let's say you took 1 month to complete electrostatics, or like let's say 1 month to complete current electricity. After that 1 month, your speed will remain somewhat the same, but if you start practicing every day, 30 problems, 20 problems every day on that current electricity, your speed will increase exponentially. Initially, you'll see that you're taking 5 minutes, maybe like even like sometimes 10 minutes, 20 minutes for a problem, but that is because you haven't seen that concept yet. Okay. But over the time, it will happen that you have started solving the numericals, you understood that equations, what should be used, and what is the concept around it. After some time, it's going to take really lesser and lesser time. You'll start solving it in 2 minutes, 3 minutes and on. And more test series, guys, more and more test series, your speed will increase. Okay, so this is a good question. So this is a very conceptual question. An ammeter is connected in a series to a circuit containing resistor and a voltmeter. Okay, and is connected. Okay, an ammeter is connected in series to a circuit containing resistor, and a voltmeter is connected across the capacitor. Okay, you are basically measuring the current in the circuit and the potential across the capacitor. It was found that the reading on the voltmeter and the ammeter was continuously reducing. Then what you can state confidently, whether it's a charging capacitor or a discharging capacitor circuit, or a combination of one capacitor is charging where the other capacitor is discharging, or it is none of the above. Yeah, but for speed, guys, do as many. If you already have subscription, do as many test series as possible, attend as many quizzes as possible. Like what Akash is saying, take up DC Pandit, take up HC Verma, solve them. Initial basis, it is going to take time, but that is fine. That is for everyone, right? Why for target of JEE 2020? Alright, any guesses, students? What should be the type of yes? No. So in charging, what do you observe? If you have put, like let's say, like it has been told to you very subtly that there is a voltmeter across the capacitor, and you're basically only aware of two things right now. One is your ammeter across the resistor. So you are observing decreasing potential and decreasing current. What it is? So decreasing potential means decreasing charges across the capacitor. So decreasing charges across the capacitor, decreasing current. What it should be? It should be B. Yes, right, Akash. It should be a discharging capacitor. It's not a charging capacitor. Charging capacitor, if it was charging, what would you observe? You would observe that the current will decrease. That's correct. The current will decrease, but your potential will increase. So I'm just marking it with red. If it was charging, what is going to happen? In the ammeter, you're going to observe decrease in current, of course. Okay, with time the potential will build up. It will start blocking, the potential. It will develop a reverse polarity potential, and you'll observe decreasing current but increasing potential across the voltmeter. But since you observed, decrease in potential and decrease in current, that is a case of discharging. If you had observed decrease in potential and decrease in current, that is a case of discharging. Right? That is simple conceptual. Let's move on to the next question then. Yes, careful guys, careful. So yes, what about this question, guys? If a battery of EMF 6 volts is connected across, the battery, across the capacitor in the given circuit. So what would be the potential difference after long time? After long time, steady state, they are the same things. So what is the potential across the capacitor after a very long time? 6 volts battery is over here. Observe this network. What would happen after very long time? Yeah, both of them. Yes, that's fine, Brunel, that's fine. So what happens after very long time? It's a steady state. What is happening? What should be the potential? Yes, it will become an open circuit. But is it actually an open circuit, or is it something like, it is basically blocking this potential? Okay. Option B, that's correct. Yes, it's 3 volts. Amazing. So yes, we discussed this concept, even before in the capacitor class, but this is not the gist of this concept anyway. We're going to get into something very interesting, but for the moment, let's analyze what is happening. It has built up some potential across it, okay, such that it does not allow any current to flow through. When is that possible? That is only possible. Let's call potential developed over here is x, and we are assuming this is like 0. Okay, and this is also going to be something like x and something like the potential over here. The current would not flow across this resistor. Okay, if I is equal to 0, I'm going to say, I'm just going to take a different color. That means this too has to be at x. Okay, this too has to be at x, this has to be at x. Okay, when is that possible? That is only when possible that these two are at same potential, that current is 0, right? So try to understand this. We are running a nodal analysis. I know most of you know the answer, but try to grasp this concept quickly. Okay, so that is when the current is 0, no potential difference, delta V is equal to 0, that means I is equal to 0, right? And that means what is the potential across this? No current flows through this, but 6 volts has to drop. And this R and R in series. So R and R in series means if 3 volts drops across this in steady state, we are talking about steady state. So this would suffice it, right? So this is as if one R resistor and 1 R resistor in series. You'd analyze what is the potential. If this was 3 volts, that means X is equal to 3 volts, and that means X is equal to 3 volts. That means the potential across the capacitor is also 3 volts. Right? If it was 2R, that is going to be, it's going to drop in the ratio of the resistances in series. Okay, that time X would become, so let's do a thing, let's pick up a different color and do this thing. Okay, yeah, students, this we have discussed earlier. Complete it if you haven't completed it. So if R is equal to 2R, that means, that's really quick guys. Yes, that's awesome, amazing, Akash. So if it was 2R, this R and R in series. So R and R in series, the potential drop would be in the ratio of R, and in that case, what is the value of X? If 2R, the value of X is going to be, so here you would have 2 volts dropping across it and 4 volts dropping across it. And another way to understand is that I'm saying no current is flowing through it, but some potential is dropping across this. You can run a loop analysis in steady state. Okay, you can do this later. Anyway, let's get into the most important concept. Any doubts? Okay. All right. How about this? Any guesses, students? If the EMF of the battery is 6 volts, when does the capacitor get charged to 67% of the maximum charge it can obtain in this combination? How would you do this question? Anyone who is aware of the trick? Or we should actually go through this method, like just we discussed what is the potential and you would draw. So this is not a steady state, guys. Okay, this is not a steady state because it's not building up all the charges across it. Okay, it's only reached to 67% of its maximum charge. Okay, 67% of the charge it can obtain in the combination, right? So how would you do this question? Anyone who has solved it? Let me tell you something. You don't have to be worried about this potential across the 6 volts. This is irrelevant to your calculation. All that resistors is what, it determines not the time constant, of course, right? When does it? Yes, we'll discuss that, don't worry. That's correct, yes. Amazing question, yes. That's option C. Let's understand why it is option C. So let's first go through, we'll solve a few problems using the method. The method we should be using, traditionally be using to solve such problems if you are given such questions. So as usual, you take this as X. This is 0. And in steady state it's going to be X, but not in steady state, means at time t is equal to 0. time t is equal to 0, what is happening? Charge q is equal to also 0, no charge, right? So q naught is c. We'll see what is q naught. We don't require q naught at all, but anyway, at time t is equal to 0, q is equal to 0. At time t is equal to some t, let's call q is equal to some q. What is the current? So if charge q has been built up across this, okay, so what is the potential drop on this capacitor? Q by C, and what is the potential over here? X, right? The current that is going to flow on this resistor is dependent upon two potentials. One is Q by C and this X, right? Can I say something like this? Can we write down, the current across the resistor? This resistor is what we are talking about at this moment. So let's call this as, like I2, and this as something like I1, and this as I. The total current is I flowing through the circuit, I2 is flowing through the resistor. So do remember, it's not a steady state. So there would be some current flowing through the capacitor until it reaches that steady state that is going to be after a very long time. That means always there is going to be some current that is going to flow through the capacitor, right? And what is I2? I2 is equal to how much? X minus Q by C divided by R. So I'm just writing it down as 1 by R. I hope this is visible. Yes, okay. So you understood this part of it. Let's just, what you're going to do is basically apply junction law. This I current is flowing through this way. If this is I2 and this is I1, okay, we are analyzing at some time. At time t is equal to 0, q is equal to 0, right? You know this. And at time t is equal to t, what is happening? We are assuming some q is equal to q. Just like how we did earlier, guys. That's why we did the derivation. Okay, I could have just directly told you the equations, but it is necessary, the derivation. Now, given any kind of problem, how to solve it. Okay, let's assume there is some potential x across this, and this is going to be 0. Some charge q has accumulated on it. There's of course easy way of doing this problem, but let's first of all understand, because this is a simple circuit. What if you had 3 capacitors, 2 capacitors, and multiple resistors in different resistance combination? You should be able to solve it. Okay. So yes, now one thing we know is I1 is equal to, we just derived it, I1 is equal to this is Q, this is going to be Q by C, that's a potential drop across this capacitor. So X minus Q by C into 1 by R. In this case, I2 is simply X by R. X is the potential dropping across this. I'm writing it down as X by R, right? And what about I? I is going to be some V minus X by R. Okay. So for I, what is happening? This potential V minus X by R. Is that what you're doing? Yes, you're going to do this. And then immediately you're going to say, after this, I is equal to I1 plus I2. Standard method, guys. Very, very, very standard method. If you forgot anything, this is the standard method to solve these kind of problems. T, and I didn't get your question, Roshan. Krunal, yes, we'll solve some problems. Yes, this is the last concept, guys. Okay. What is your question, Roshan? I didn't get it. T and Q, can you repeat it again? So I'm going to just write down this equation and solve for it. That's what we need to do. So I is equal to I1 plus I2. Any given question, this is the standard method, students. Standard method is going to be this. That's it. Okay, you know how to change it according to it, but you are going to follow the standard method, right? So we just derive the value of I is nothing but V minus let's just write down V minus X by R is equal to X by R I1. I know most of you know how to even do this thing. This is I2. I2 is going to be through the entire thing. Okay, it's also the current flowing through the capacitor. Okay, and what is this? This is X by R I1. Write down X, then do this. I'll tell you something even more easier, but first of all, let's do it this way. Few problems, we need to do it this way. Q minus C, X minus Q minus C. Yeah, I mean, you can write it anything you want, guys. Like T is equal to maybe like T dash. But since we are deriving a standard equation, we are writing down T is equal to T and Q is equal to Q. Okay, you can write it down anyway. Yeah, Roshan, that is fine. In this case, we just wrote it that way because we want to derive a standard equation, right? In terms of Q and R, and understand its behavior with respect to Q naught. And you know what is the Q naught across this, right? The final potential. Final potential in this case is going to be 3 volts. V by 2. It may differ from depending upon the type of the circuit in these kind of circuit combination. Okay, and we are going to solve this to find out the value of X, and you take this X on the other side. It's basically 3X by R is equal to V by R plus of Q by C. That is going to be an RC. Okay, this R is going to come inside. Okay, that is it. That is all you have to do. Okay, now initially you will find out what is the value of X, and what is the next immediate thing you are going to do? You are going to solve for the current. Okay, you're going to solve for the current. X by R, and that's 2X by R, and that is 3X by R. This is going to be plus. Okay, and R will cancel out, R will cancel out, and what do you have? You have some simple equation that's going to be something like V plus of Q by 3C. V by 3 plus Q by 3C. Okay, that's it. Time of Q is good question. So Kruna asked a question. So there is an easy way of doing this kind of question. So why are you first of all teaching us the derivation and then talking about the final result? The reason is, what if we have 2 or 3 capacitors in series, and what if at the moment you forgot the method? And it is very important to understand, that short trick that you're talking about is the final result, right? It's not actually the way you should be solving the problem. So that's the reason we'll be, first of all solving it. Once we have solved 2 or 3 problems, you are accustomed to the method. Then we'll see that, okay, this is the way to do it. So how did we actually come to this conclusion is what we are deriving initially. Okay, any complicated circuit, you can adopt this nodal analysis method. This is known as nodal analysis. You are assigning some potential to the each nodes, each junction, and then you are deriving the equation. That's a good question, but why have you derived the entire equation for the capacitor, discharging and charging of capacitor? If people are just starting with that, Kunal, it's going to be like I just can't admit it. If it works that way, if you haven't given me a justification. And this is true for many people. Okay, and okay, so we are near X. X is equal to V by 3, and what is the equation that we are going to work around with? So we are only worried about, I'm just right now writing down this as some I dash, which is nothing but saying that I dash is equal to, what is this I dash? I dash is basically the current through the capacitor. The current through this resistor is same as the current through the capacitor until it reaches the steady state. Okay, and this is Q by C. This is X. So this is X minus some Q by C is time T is equal to time T is equal to T implies Q is equal to, that's what we are doing now. And I'm going to substitute the value of X. What is that X? D by 3 plus of Q by 3C. That's what we have, right? And minus Q by C. Yeah. One is you're not able to admit things. The other reason is, why would you admit things? That there is also a reason, right? You need to first of all understand the proof, why it works, how it works. And the other reason is also, you don't want to, sometimes it happens in the exam that you're confused whether the method that you have learned is correct, and any complicated circuit, right? This I dash, I'm writing it down as dq by dt basically. Okay, I dash is nothing but dq by dt. Okay, and how much is this? V by 3 minus 2q by 3c. Is that what we are getting? Yes. We need to make a common denominator. That's going to be c minus v by 2q by 3c. Yes, it's of course a very, 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 very long method. You don't have this much time in your exams. Of course, this is not something that you have to do unless it's a 5-mark question or a numerical question. You don't want to spend this kind of time. Okay, so dq by dt. So you understood the method, right? You understood the method. Initially, you will assign some potential to the nodes, and then you find out the value of x, and then you will write down this equation. That's it. Now, post this, it's like an integration problem, right? So I'm going to solve that integration. dq by cv minus 2q. We are going to see something interesting, of course, by the end of this lecture, and that is going to be 3c. Okay, dt by 3c. Was it? I think it is dt by 3c. I'm sorry. dt by 3cr actually. Okay, we are missing some r somewhere. I don't know where did we miss the r. I think we didn't carry the r from here. There should be an 1 by r, there should be an 1 by r, and there should be a 1 by r. Okay, so I is equal to q minus c into 1 by r. I'm really sorry, students. Okay, this is 1 by r. Okay, this is a different thing. This you know it. Anyway, you know this thing. So there should have been a 1 by r. Right? We wrote down 1 by r. And remember, you will always have an r combined with c when you are talking about time constant, L divided by r when we are talking about time constant. Right? So that's it. So you did all of this, you got until like 3 RC, and I think by now you have guessed the time constant is 3 RC by 2. Right? So anyway, let's integrate it and let's see if we are getting the right kind of equation. How do we verify whether we are getting right kind of equation? One is like, you analyze that t is equal to 0 and t is equal to infinity. Okay, so you do this integration, it's going to be something like, 3 CV minus 2Q divided by minus 2. This minus 2 would be there. You can take this CV minus, if you have any issues in the integration now, you can take this as CV minus 2Q as some x, right? Some CV minus 2Q as x. Morning, your class starts at 2:30. So yes. So you one of the things you can do is, if you're totally you don't know how did we get this. So one of the ways of doing it is, you can take CV minus 2Q as some X or Y, whatever you would like, and then you would solve it. Okay, and then two things you need to write. This would be X, means what is the value of dx? Dx is going to be minus 2Q dx, minus 2 dq, sorry, minus 2 dq, right? That is it. So what is the value of dx in that case? Dq in that case, you need to substitute dq. That's going to be dx by minus 2. You substitute it, you will get this thing, right? You can do it this way. Okay, but anyway, to understand, if minus 2 is over there, you will get a minus 2 on the denominator. And yes, if you integrate dx by x, it's going to be log of x. Right? That is it. And you integrate it on this side, it's going to be, and from where to where would you integrate this? You would integrate it from 0 to some q. So no confusions, guys. There is nothing to be confused about. Some charge q builds up on it. So if it's a discharging, how would you do that? If it's a discharging, you would assume it's going to be, if it's discharging, you can basically take up the equivalent resistance and do it, right? That's going to be as simple as that. If there is a charging and discharging, for the discharging, you are going to say it's going to vary from Q naught, initial charge, to some Q, and 0 to time t. Okay, that would come in the case of combination. You can expect it very rarely, students. Very rarely means very rarely. Okay, this is something that you can expect in your JEE Advanced, especially because this is a very simple concept. So yes, there is going to be like 0 to t, and if you integrate this, you take the minus 2 on the other side, so it's minus 2t by 3rc, and what is over here? Log CV minus 2q minus of log CV itself, CV minus 0, right? What kind of guidance class? Like, I didn't get your point. So what is the kind of guidance class that you're expecting, Krunal? Is there any specific kind of guidance class that you're expecting? Okay, there is no space, I guess. So yes, if you you understood, this is the time constant, right? 3rc by 2 is going to be a time constant. So let's do a thing. I just wanted to solve the entire thing. It's pretty long. Okay, and let's do a thing. I'm going to erase this part, maybe. Let's erase this part, I guess. You understood how to do this. So yes. So we got an equation something like this: ln CV minus Q minus ln CV natural log CV is equal to minus 3t by 2rc. Oh no, 2t by 3rc. Okay. 2 minus 2t. Minus would be there always, don't forget it, okay? And yes, that is it. So as usual, log operations, exponential operations, you do that, you would get your answer. Okay, log CV minus Q by CV is equal to minus 2t by 3rc. So 3rc, yes, it's 3rc. Yes. General doubts. I mean, like doubt clearing sessions, we can do that. But is there anything in specific that you're expecting? So you take an exponential on both sides. So it's going to be CV minus Q. I'm just writing down it this way, by CV is equal to e to the power minus 2t by 3RC, right? So this is going to be 1. And if I'm going to carry this, on the other side, we're going to have a pretty interesting equation. Are we missing out something? We are missing out something. That is 2q is what we are missing out. I'm really sorry. So next one we'll take it up, quite quickly and do it. There should be minus 2 and there should be minus 2. Pretty lengthy, right? Don't worry about it. And then we'll go through some simple method of solving this problem. We'll do a couple of problems this way. Yes, it's going to be. So I'm just carry forwarding this equation. Right, and 1 minus 2q by CV is equal to e to the power minus 2t by 3RC. Pretty lengthy, guys, and agree. You do this, you'll get it as. So I'm going to write down q is equal to, move this e to the power on this side, you're going to get something like CV by 2 in this case. So, and one more thing, guys, why do we need to derive? Like, you need to at least derive it 3 or 4 times to make sure that your shortcut trick works. Okay, it's not actually a shortcut trick, it's known as a method of superposition. You can do that as well. It's like a theory. Okay, we'll do that for now. Okay, we'll do that session, guys, don't worry about it. Something interesting. So now let's evaluate whether the equation that we got is correct or wrong. Okay, and that's what that is something that we need to do, right, to make sure that our this thing works. Let's see how it works. So time t is equal to 0. What should happen? A time t is equal to 0, it should be 0. E to the power something 0, it's going to be basically, q is equal to CV by 2. It's getting messed up. Okay, let's move a little bit slowly, and I guess that would be better. Q is equal to CV by 2, 1 minus of e to the power 0, which is nothing but 1 itself. So that's going to be 0. Yes, we got it. At t is equal to infinite, what is happening at steady state? You cut down this current across this resistor and you say that this potential drop is nothing but potential drop across the capacitor. And that should be, in this case, V by 2 or 3 volts. Right? So yes, let's see. T tends to infinite. Q is equal to CV by 2. Okay, and what should be the charge? You know that it is QCV by 2, and e to the power 1 minus e to the power minus infinite, that's going to be 0. This is 0. That means this is equal to CV by 2. Right? Q is equal to, when t tends to infinite, it's CV by 2. And what about your VC? When t tends to infinite, it is going to be V by 2. Are you getting the right kind of answers? Yes, I guess so. Let's check it out. Yes, it's going to be V by 2. Right, we just did it. Or 3 volts in this case. So we got this equation. This is what determines our our equation. And what is the time constant in this case? Time constant, just going to choose a different color for this time constant thing. Let's observe this case. Time constant comes from here. So I told you your this entire time constant is independent of your the voltage that you apply across that capacitor. So time constant tau is equal to, in this case, this equation should be in the form of e to the power minus t by tau. Okay, let's understand this point. So this equation over here should be in the form of e to the power minus t by tau. So if your minus t by tau is equal to minus 2t by 3rc, what is your tau? Tau is, cancel out this t and t, it is 3rc by 2. Right? So yes, that is something that we had to understand. This is the time it takes for 67%. Tau is irrespective of anything, 67%, right? If time t is equal to tau, what is happening? 1 minus of 0.37, that is only 63% of the charges. Yeah, for time is equal to infinite, yes. This equation would not exactly work. We will see the method, okay? We'll see the method. Don't worry, Kunal. Stay until the end of the lecture. We'll see the method. We'll solve, 2 or 3 more problems of this kind, and we'll see the method how to do that, okay? So tau is equal to 3rc by 2. What is happening? It is basically at t is equal to tau. If you are noticing it, what is happening? Q is equal to Q naught. This is actually Q naught, right? Maximum potential can be only CV by 2. So I'm going to call this as Q naught. Okay. Q naught into 0.63. 1 minus E. 1 minus 1 by E. Sorry, 1 by E is 0.37. Right? I hope you understood this part. That's it. So the answer should be 3RC by 2. Really simple. Let's move on to the next question, a very similar question. Now we have 2R over here and 2R over here. See students, I'm getting you different kind of model problems around the same kind of concept. The reason is you need to not get confused in your exam. Okay. While we are doing even the like the superposition analysis, removing this battery and assuming this as the voltage source and moving into this problem, you should not get confused. Okay, that is the reason we are entirely doing this. Alright, there is a 2R over here and a 2R over here. The same thing is being asked. I'm quickly jumping into the solution. It's 67%, and that means I'm asking you, what is the tau? Any guesses what is the tau? This method will work for everything, Kunal, but this equation will work for everything is a wrong claim. Okay. We will understand what is that equation, why that comes also. We can understand that part. It's not a big deal, but yes, for now let's get started on this. Okay, let's move on, and the same thing will happen over here as well, and that is going to be some charge. I'm going to assume same ditto procedure, guys. Ditto procedures, nothing is going to change. It's Q, this I'm going to say is I, and this is going to be I1, and this is going to be I2, right? I is equal to I1 plus I2. This time I'm just writing it down directly to find out X. Okay, we have to find out X. Potential X. So this nodal analysis based problem. I've seen a lot of questions in your not this exact problem, but this where you assume it to be X as the thing I've seen in your JEE Mains especially. Okay, so what is happening in this case? V minus X by R, that is I, right? That is I, right? V minus X by R. Okay, by 2R, sorry, by 2R. And what about the I1? I1 is X minus 0. I'm directly writing down as X by 2R. And what about I2? I2 is nothing but X minus 0. No, sorry, X minus QC. X minus QC by R. That is it, guys. Now you derive the value of x. I mean, you find out the value of x. The same old thing is what you have to do. Yeah, Kunal, it's up to you. Yeah, we'll get into the method quickly, okay? So it's up to you guys, yes. And continue watching it, continue understanding the method, and also practice it, twice or thrice. Once you have seen this method, same problems will also work. And finally, do understand why that method works, okay? And that being said, what is it going to be? We have to find out the value of x, and that is going to be 4x by 2r is equal to, how much is this? This is going to be v by 2r, right? V by 2r, and we have something like x by qc. Okay, just carry forward this equation and keep the value of x very safely. And v by 2r is what we have, x by 2r, 2x by 2r, 4x by 2r. Yes, that is all correct. Okay, 4x by 2r, and we have here plus q by rc. You don't forget the r. Okay, so yes, q by t. Okay, you can balance the dimensions. So we got something like 4x by 2r is equal to something like v by 2r. But make sure, students, if you're skipping this part, you practice this on your own again and again, so that you're getting accustomed to this method, and we'll understand also the shortcut that you're talking about. Okay, so no, this should be just RC, I guess. Okay, let's quickly go over this method, and what this should be simply be, r would cancel out, and you would have like a 2 that would come over here. That means the value of x is nothing but v by 4 plus q by 2c. Right, this is the value of x. Now let's get started directly with the equation. So what is the next thing that you have to do? You have marked this as x, you have marked this as 0, you have marked this as q by c, and you need to find out at time t. Okay, at time t is equal to t, q is equal to q. Right, that is what you are going to do. And let's choose a different color and let's move on. So what is I is simply, you're only worried about this I dash or I2 or I dash. So that is what you're worried about. That is nothing but the way the charge builds up on this capacitor, which is going to be x by r is what is the current. How much is that? V by 4r plus q by 2cr or rc. Okay, you have to solve this equation as usual, and okay, you can practice how to solve this equation. It's going to be dq by that is going to be dq by cv plus 2q, dq by cv plus 2q. Is that correct? Yes. Is equal to something like no, if only time constant is asked, you need to only necessarily solve until this part where you understood the time constant's values. How much? 2c, because if you integrate it, there will be a plus 2q that will be coming out. Okay, we did a mistake, guys. Okay, let's go through this. Let's take our time. Okay, so what is that mistake? The current is not x by r. The current is x minus qc by r. I don't know. I think it started already. I'm not sure. X minus qc by r. Let's go through this patiently, guys. Okay, 1 by r. Right, else this would mess up. V by 4 plus q by 2c, and that's going to be x minus q by c. Is that what we need to get? Yes. Is that what we need to get? Yes. X is equal to 2r, 4r, 4c, yes, 2c. And that is going to yield some equation in the form of, anyway, that should have been minus q by 2c, and so this would come out as dq by dt is equal to, there should be a 1 by r, don't miss it out, and that is going to give you, do it numerous times, students, like, this is the part where you need to work in the charging and discharging of capacitor and some tricky problems around them. Okay, this is a very important calculation. So you saw the derivation was actually useful, like everywhere the derivation would be useful, because that is the fundamental concept, right? We are deriving it from the fundamental concept, very basic things. Nodal analysis, post that you write the current, you say this is q by c at time t is equal to t, and then you start solving the equation. So let's do this. It's going to be dq by dt is equal to v by 4 minus q by 2c, just pardon me for a moment, and let's move into this 1 by r, right? Pretty lengthy equation. Let's do a thing, and we need to do something like find out the time constant. Okay, time constant is actually 2rc, I guess. So anyway, this is going to be dq by v minus cv minus 2q. We did cv minus 2q integration just now, so we don't need to work really very hard, but this is 4rc. I'm going to integrate on both sides from 0 to q and some time 0 to t. Is Newton's second law universal? It's universal but not applicable in all cases. Newton's law is only valid in inertial frames, and as such Newton's second law would fail in some cases, but that is universal, right? It's universal. It is universal, yes. Cv minus 2q, and you're going to integrate it from 0 to q, and divided by how much? Divided by minus 2. Divided by this is going to be plus q divided by minus 2. You have this minus 2 over here, and you know what is the time constant now. This should be just 0 to t, and this should be 4rc. So yes, you're going to get 2. You can simplify this equation. This is log, guys. I'm sorry, this is log. And this log should be integrated from, you integrate this. I told you how to integrate this kind of things. Okay. Of course, 1 by q, it's going to be log, and in the denominator you're going to get minus log. So it's just 0 to like q, and after solving this you're going to get something like log. We just did this problem, minus 2q minus log cv. I'm just writing down it straight away, minus t by 2rc is what you're getting, already the time constant. Okay. And yes, this is going to be directly q is equal to, we'll do the detailed solution for one of the other problems, but this is going to be q is equal to cv by 2 1 minus e to the power T by 2 RC, and is this equation correct? Let's verify this. So you can verify that, and let's say at time t is equal to 0, you are going to get Q is equal to 0, since it's going to be CV 1 minus of e to the power 0, which is going to be 0, and t tends to infinity, Q should be, so right now you know what should be the potential drop. That is going to be the potential drop in steady state is going to be the potential drop across this resistance VC, whether we need to see if it's correct, and if it's 2R and 2R, how much should be the potential drop? It should be V by 2. Okay, so we should get something like CV by 2, CV by 2, 1 minus of e to the power minus infinite, that is going to be CV by 2. That means that Q t tends to infinity, it should be CV by 2. And what about the potential? Potential at capacitor when t tends to infinity should be V by 2. We are getting it. Okay, but that alone does not confirm our equation. We should have derived rest of the time constant thing also pretty accurately. Okay, that is also very important, guys. Okay, this is the most important part. This is where your questions will come from. Time constant is where you will get your questions. Okay, time constant, time taken to charge so much, time taken to charge it to 50%, you can find it out. Now you know how to find out even for 50% given, you can derive this equation. Okay, and that being said, let's move into the next question. So in this case, what is that tau? The tau is going to be, so this is in the form Q is equal to Q naught 1 minus e to the power t by tau, right? And our t by tau is how much? Our t by tau is equal to t by 2 RC, and our tau is 2 RC. That's it. Okay, simple. So that should be B. And let's get into the next kind of this problem. So now you have unequal resistances, all unequal resistances. Earlier you had at least, initially you started 3 equal resistances, then we went to, 2 equal resistances, and, now we have 3 unequal resistances. Same problem, we need to find out tau. Okay, so how do you do this problem? Same thing, same procedure. X 0, find out the value of X, and then you would have this minus Q, plus Q, and this minus Q, this is going to be Q by C, then you are going to write the current. Okay, let's do this as quickly as possible and move into this next concept, that is the most important one, how to solve any problem around these kind of questions. Solve it parallelly, guys. Okay, by now you understood the method. So what is this? V minus, okay. So think about it, like how we are solving it. This is going to be I, this is going to be I1. If you understood it, well and good, students, but still solve it, because it is very important that you solve it throughout. Okay, your IIT JEE is all about solving problems. If you haven't understood that now, and understanding the problem, right? Understanding concepts, solving the problems. Be it physics or math or even chemistry, in most cases it's about solving it. V minus X by 3R is equal to X by 6R plus of X minus, okay, I got a shortcut, I guess. Okay, I'll share that shortcut with you then. But we don't need to actually solve the entire thing, students, if you observe something. Okay. Okay, okay, anyway, we need to solve it, right? Can we do it without solving the entire thing? This is 2RC. No, this is not 2RC, I guess. Roshan, do it again. This is not 2RC. This is going to be 3RC. Okay, let's do it. So your value of X. So I'm directly writing it down, and that should be X by 6R in all places. So here you have 2X, and here you would have 1X, 3X, 3X, and 6X. That's going to be 9X. 9X by 6R. Okay, X by 3R. So it's going to be 2X by 6R. 2X by 6R plus X by 6R. That's going to be 3X by 6R. Plus of another 6 X by 6R. So it's going to be 9X by 6R. And what about this? This is going to be V by 3R. Plus of, this is standard, right? Q by just RC, that's it. Okay, this is going to be very typical that you're going to face. This is 3, this is 2, and there you go, you got the value of X. You cancel out all the R's. Maybe you don't even want to write the R's while you're solving it, but anyway, for now, just you may need to solve it again and again so that you get the speed, guys. Okay, that's very, very important. And also try to solve for different kind of problems where you have equal resistances, unequal resistances, 2 equal resistances, one unequal, one equal, these two are equal, and then this is not equal. Try to derive as many as possible within, if you're watching this video today, do as many as possible today itself. Okay. And sorry, this should be after some time you had asked me later, how would you solve the problem quickly? Yes, this way it would happen. That's going to be 2Q by 3C. So this is your value of X. And the next thing is, so we did for, this is first method. Okay, first step, this is your first step. Your first step is find X. Second step is going to be I is equal to dq by dt is equal to X minus QC into 1 by R. Okay, so apply the current equation. That is your second step. Okay, and that being said, now what is your I? This is going to be dq by dt is equal to, what was the X we derived? We derived something like, I guess, 2v by 3 plus of, so we also have something like 2q by 3, just a moment, students. So this should be not 2q by v, but just only 2v, I guess. 3, that would be 9. There should be 9, right? There should be 9, and yes, 2v by 3. Okay, that is going to be 9. Then we got this correct. Yes, 3, 2, 2v, 2q by 3c, right? The circuit. Start solving it. The answer should actually be 3RC. Okay, the options were RC, 2RC, 3RC, and I guess 0 as usual. So here you are 2V by 9. Okay, let's understand this part, whether we have done this equation correctly, else everything would mess up. Yeah, 3x by 6r, 9x by 6r, that's 3 by 2, and we have v by 3, and v by 3, that's going to be v by 9, 2v by 9, and that is going to be 2q by 3c. Okay, 2q by 3c minus q by c into 1 by r. Right, that is it, guys, that is it. what you're going to do, you're going to do the same typical thing. You're going to write dq, okay, dq by dt is equal to 2v by 9, not q, that's 9, okay, 2v by 9 plus of and minus of q by 3c. Is that what would you get? Yes. 3q by 3c, that's going to be q by 3c. Minus q by 3c into r would still exist. So yes, that r, don't forget that r. And that is going to be dq divided by 2v 2cv and this is going to be 3q, right? And what is this? On the denominator it was 9c, I guess, right? 9c. Yeah, 9c. So it is dt divided by 9rc. That is it. Integrate on both sides, and yeah, Newton's second law as such is universal. Yes. It is not applicable in non-inertial flames. Newton's second law is not supposed to be applicable in the non-inertial flames. It mentions in the beginning itself. Okay. And that being said, so yes, your lecturer might have told that it's not universal, depending upon case by case basis. But universal means you can apply it to a broad set of cases. Okay, if you ignore friction and if you ignore those things, then it is applicable, right? So this would give an equation, sorry guys, so the equation was something like this: dq divided by 2cv minus 3q, and this was from 0 to q, and this is from 0 to t. And what was this? This is like dt by rc. That's what we have, dt by 9rc. Let's verify it. And this was supposed to be 0 to q, and this was supposed to be 0 to t, right? And what this should be, t by 9rc after integration, and that is going to be 0 to t. Sounds very mathematical, but you can't help it, guys. And what about this? One thing you can do is you can take out 2 common or let it go. Okay, let it go, and you just take this as this thing. You would get on the denominator minus 3. How do you do this? I told you, right? You take this thing as some x. Take this thing as x. X is equal to 2cv minus 3q. Get accustomed, guys. And dx is equal to minus 3dq. Is that correct? Yes. Simple differentiation, right? There is no complicated differentiation in this case. Minus 3dq. And what is dq in this case? Dx minus 3 divided by minus 3. So that's what we did. We didn't do anything different, and we got the same result. Now we have substituted the value of x. You would also eventually substitute the value of x over here, but you are going to do the same thing. X is equal to 2cv. You're going to put it 2cv minus 3q, so it does not matter. Okay, until here, if you have any confusion in differentiation, you can do until here. And that being said, this is going to be 2cv minus 3q, and you are going to integrate it from 0 to q. So that is, you understood it's 3rc is the time constant, isn't it? Yes, time constant is 3rc. Let's see if our t tends to infinite works and t tends to 0 works. T tends to 0 will of course work, guys. Where t tends to 0 will work, there is no issue in t tends to 0, so that is not a problem. Okay, but the thing you have to verify is at the end whether you are getting, if you have done all the derivations correctly, at t tends to infinite, how much should be the potential drop across this? So this is 3R, this is 6R, it's in 1:2 ratio, no current flows through this. At steady state, how much should be the potential drop across this? The potential drop across this should be 2V by 3. Okay, 2V by 3, that means capacitance at steady state should also have 2V by 3. Let's verify whether, so this is the way to verify whether your derivation has gone right or wrong. Okay, this is a method. And about your time constant, probably don't miss out R. That is something maybe we often do. And that is going to be, this is going to log, right? Sorry, this is going to log. Log. Okay. Anyway, that is going to be 2CV minus 3Q. I'm directly writing it down. It's log minus log. I'm just directly writing it down. 2CV minus log divided by what? 2CV minus T, minus comes over here, minus T by 3R. So you already understood the time constant. Tau is nothing but 3R. You got the answer. Okay, rest is just to verify. Rest is if given an equation. Let's say give me the equation of this capacitor, then you should be able to do it. For any value of capacitance, for any value of resistances, you must be able to do it. Shortcut is take this as V. I mean, like for deriving the equation, take this as V and solve it. We'll see there is a very simple method of doing this. So let's move on and derive the equation completely. And so we got ln. I think that was 2CV minus 3Q. That's what it is by 2CV. Let's verify. And we had something like minus T by 3RC. This is after integration, right? Yes. Okay. And raised to the exponential. Okay. Raised to the exponential, this would become just 2CV minus 3Q divided by 2C, and what about this? This is going to be e to the power minus T by 3RC. Simple. Right, and you take the same thing, you do the same thing, you would get Q is equal to, okay, what would you get? Q is equal to something like 2CV by 3. I think we are getting what should have we got, right? So derivation was correct. Right, this is your equation for your so tricky concept, but a very easy one, guys. Okay, so this is going to be Q is equal to 0, Q is equal to 0 at time t is equal to 0. You can verify this. At t tends to infinite, what is happening? Q is equal to, so you know what is going to happen over here. It's going to be infinite means 1 by infinite 0, and that is going to be only 2CV by 3. And what about VC when t tends to infinite? It is 2V by 3. Right, is this correct? Yes, I guess so. This is correct. If this is steady state, at t tends to infinite, what is happening? Potential drop across this is VC. What is the potential drop across this if the current is only flowing through this path, and current over here I steady is equal to 0? That means the current through this path is all the current that you have. And how much is the current in this case? It is basically V by 9R. V by 9R into 6R. How much is that? VC is equal to V by 9R into 6R. That is 2V by 3. Did we get that? Yes, we got. So one way of verifying this. Yes, 3 over. Yes, that is correct. Yeah, that is it. That is all you need to understand, students. This was the basic concept around this kind. Any problem, any kind of combination. Take that node, find that node potential in terms of knowns, and then even you can put it in numbers, right? You can put it in numbers, right? So yes, and then you would write down the equation for current, and you would do it. Right? That is it. So now we did a very similar one. We did a very similar one. What did we get over there? Instead of 3R, there was a 2R. Right? So there was a 2R, here it is 3R under 3R. Right? So let's do a thing. I'll just maybe quickly write down the equation and see what happens and what should be the equation, whether we are getting it correct. This is I and this is I1 and this is I2. Right? I is equal to I1. So first, step number 1, x 0. So I'm going to go step by step. Step 1 and so okay. Let's not hurry up. So step 1, this is x, this is 0. And this is plus q and this is minus q. Okay, and this is v. Okay, that is all we need to do, and we need to write down this current I, and this is going to be I1 and this is going to be I2. And step 1, find x. You should be accustomed by now, I guess. In fact, I am accustomed too much to this. Find x and what it should be now. Okay, this is q by c, that you know that. Okay, so x v minus, I'm directly writing it down. That I is equal to I1 plus I2 is what I'm going to write down now, and I is equal to I1 plus I2. Right? This is true from your junction law. And that means V minus X V minus X by V minus X by 3R is equal to X minus 0 by 3R I1 X 0. And how about I2? I2 is X minus 0 by R, X minus QC. Okay, X minus Q by C. Okay, at some time T is what we are analyzing. It is Q by C. I'm assuming that it is at time T because some charge Q has accumulated on it. Okay, so X minus QC into 1 by R. And what is this? This is going to be 2, 3, and it's going to be 5x by 3r. Right? X by 3r plus x by 3r, 2x by 3r, and x by r. You're going to say it is 3x by 3r. This is 5x by 3r. And this is v by 3r minus of q by rc. R gets cancelled. and you can take this 3 by 5. So now x is equal to 3v by 5 minus q by 3q by, there should be a 3 over here, so 3 would get cancelled, 3q by 5c. Okay, v by 5 minus 3q by 5c, right? Yes. We found out x. Now step 2. And what is the step 2, guys? Step 2 is going to be really simple. You are going to say this is I, and you know the value of I dash is nothing but dq by dt, which is going to be, if this is x, this is q by c, is going to be x minus q by c into 1 by r, right? And we just found out the value of x. I'll write it down again. X is equal to how much? V by 5 minus 3q by 5c, right? And you need to substitute this. You substitute this, this is going to be dq divided by, how much is this? This is going to yield something like minus x minus, okay, we did a mistake over there. It's not minus, it should be plus, right? This should be plus. This should be plus. It gets carried over here, it's going to be plus. Okay. So yes, now you are going to do this. This is going to be this plus, okay. This is going to be CV minus 2q is equal to, I think it is 5 RC by 2, okay. And CV minus 2q is what you would get, and on the dt side, what would you have? On the dt side, you would have something like 5 RC. Okay, you understood the time constant now. Okay, once, if you don't know rest of the methods, you have arrived until this point, there are two things. You notice this, and you notice the one that would come on the denominator after integration, right? And that is all you have to do. This is going to be 0 to q. Notice at time t it's q. Okay, and now you integrated. This is going to be log CV minus 2q divided by CV is what you would get. We just did many. Okay, log, so we arrived till here, log CV minus 2q, sorry, yes, okay, you can once check out the equation. So it's going to log CV minus 2q minus of log CV, it is going to be divided by minus 2q is what you are, minus 2 is equal to t by 5 RC, right? And log, you would get it as CV minus 2q divided by CV, and the whole log would be over here. It's going to be minus 2t by 5 RC, and you take exponential on both sides, you would get it as q is equal to CV by 2. We are getting it correct, I guess, minus 1 plus of e to the power minus 2t by r, 5 r's. What is the value of tau? I'm saying this is e to the power minus t by tau. Tau is 5rc by 2. Right, this should be the time constant. So one thing we need to verify is at q time t is equal to 0, it's going to be what is the t is equal to infinite? It is going to be cv by 2. And what about v t tends to infinite? It's going to be v by 2. Is that correct? Let's verify. And this is I study 0. Right, and what about this? This is going to be okay. This is going to be this is basically two similar resistances. So this is going to be v by 2, and that is going to be v steady is equal to v by 2. All right. So yes, so this should have been, the tau should have been 5rc by 2. Now let's get into the most interesting part. Have you observed something? Yes, we have observed a pattern. What is that pattern? The pattern is very simple. This Vc over here should be something at time t tends to infinite. Okay, we can directly write down the equation of such capacitors. How do we do that? Really simple. First of all, we need to see that what is the, at time t tends to infinite, what is the Vc? Okay, that is going to be Vc infinite. In this case, it is v by 2. In any given case, you can do that. What is the next thing? The next thing is, it is known as, you're going to short this battery. What do I mean by this is, think about it as like a fully charged capacitor that is going to discharge. Be it fully charged capacitor that is going to discharge, or this capacitor which is getting charged, it's the same thing. Time constant is the same. Tau is going to remain the same for charging and discharging. And you know how to find out for discharging. How do you find out for discharging? There isn't going to be any battery. This battery would be shorted, and then you would observe the resistance. Okay, I hope you got this point. So what am I saying over here is, if this capacitor, you know how to find out Vc infinite. That's very simple. Okay, you say this is in steady state, and you find out what is the potential drop across the capacitor. Now the thing is, I'm saying that when this capacitor is even discharging, charging or discharging, equation will vary, of course. Tau remains same. Discharging, you don't need another potential source. We'll short it out. Okay. So that way we could have done every single problem very, very quickly. Okay. That is how you do. Let's get started with the same kind of problems and see whether we are getting the right kind of answer. What is the equivalent resistance in this case? I'm going to short this. I'm going to say this is equal to 0. That means this is R by 2, R plus R and R in parallel. So these both are in parallel, and this parallel combination is in series with this R. So that is going to be R by 2 plus R. How much is that? 3R by 2. If R equivalent is 3R by 2, what is tau? Tau is equal to R equivalent C. Okay, so that is 3RC by 2. right? That is 3RC by 2. Easy. So what about this? This again you short it. You know how to derive the entire equation. I'm just talking about time constant now, and this is going to be like R equivalent C. How much is R equivalent? R equivalent is nothing but these two resistors in parallel, that is R, and these two parallel combination in series with this R, that is going to be 2R. So your tau is 2RC, right? Yes, this is the, so the B should have been the answer. Okay, you can do this for any complicated circuit. Now again I'm saying that this V is equal to 0, it is discharging. Okay, and I'm calculating the net resistance. R equivalent is equal to 3 in parallel with 6R plus of R. How much is that? This is 2R, this is going to be 3R. So what should be my tau? Tau is nothing but R equivalent C, that is going to be 3RC, right? Simple. And we have that as well. We derived it, you can just verify it. Okay, and how about this we just did it, right? It should be 3R by 2 plus R, that's going to be 5R by 2. This was the last thing that we did. You could have done it even by shorting it. Okay, simple, right? Really simple. Like, we could have done everything so quickly, but the logic behind this only works if the capacitor can discharge comfortably. Okay, and like there should not be any like another potential source that would drive this capacitance into a charging. Okay, yeah, sure, you can ask me a question. And that being said, students, share this video. We discuss amazing concepts around charging and discharging of capacitors, and your capacitor is over, guys. This is all the concepts that you need for your JEE Mains and JEE Advanced preparation. We have discussed pretty much everything. Share the video, click the like on that video, and also to talk about JEE English channel, because it's an awesome channel where you get all your lectures for your JEE preparation from basics until advanced on this single platform. So do share and like talk about this channel. Do share the video, do like the video. Keep smiling, students, keep smiling. Avoid gossips, ignore gossips. Gossips are not the most important thing. Achieve your success by work, both hard work and smart work, and acquire knowledge and share it, because if you're going to share it, you're going to double and triple your knowledge through amazing brainstorming session. And students, if you're already on Telegram app, just click on to this link available in the description box below, else you can just type in JEE_English to find us on Telegram app. It's that one-stop place where you would get all the updates happening on the JEE, like that is being conducted by the JEE English lecturers, be it on Unacademy Learning app or YouTube, also any updates on special classes and etc. And that being said, students, check out this lecture on color coding of resistors. We have completed 2 lectures. One is color coding of resistors. We have completed, in fact, the A to Z current and electricity series with different model problems. We in fact started on the quiz. But for now, if you are like attending JEE Mains or something, or if you are attending JEE Advanced, do attend the last lecture. That is going to be electrical instrumentation in one shot. That happened on the next day, very next day, 1st of September. And this is about color coding of resistors, where we covered 5 different model problems and 5 different or 6 different model problems and 5 problems that appeared in JEE Mains 2019. And to attend many such special classes, all you need to do is download Unacademy Learning app. Okay, I think just a moment, I'll take up your question. Okay, what's your question? So yeah, you need to download Unacademy Learning app to attend many such sessions for free of cost sessions, special classes. All you need to do is type Unacademy, and your first search result is going to be Unacademy Learning app. Then you'll click on to this install button. So what's your question? From a tower of height h, a particle is thrown vertically upwards the speed u. Time taken by the particle to hit the ground is n times that taken to reach the highest point of its path. Okay. Okay. So this is simple, right? So your question says, so what is your question? Let's do it. It'll take a couple of minutes and do this question. So your question says a ball is thrown from height h. There are two things that you need to remember. So you have thrown this ball from this height h. It reaches certain h max, and you projected with some vertical projection. Okay, not a projectile motion projection, but vertical projection reaches h max and comes down, and it is thrown from the height h, right? This is your question, right? And what are the things given? The particle is thrown vertically upwards with the speed u, and time taken by the particle to hit the ground is n times that taken to reach its highest point. Okay, so you are saying it takes, what is it? It takes the time taken by the particle to hit the ground is n times that it takes to reach the highest point. Okay, so you're saying this is T1 and okay, this is T2, and if this is T1, there will be two T1s, right? One is to go from 0, this is height h, to h max and come back to the h max. So given to you is something like this, I guess. N is equal to T1 and time taken by the particle to hit the ground is n times that taken it by to reach the highest point of its path. Actually, there is little less clarity in this question. I guess this is the relation, and you know the rest. And you need the relation between h, u, and n. Right? Okay. So this is 2u by g, this h max. You get it from v square is equal to u square plus 2as. So that should be 2u square by g. Just a moment. We need to work on this. I think this 2u by g is the time. And v is equal to u plus at, this entire time is 2u by g. Okay. And okay. But they are only talking about one side time, that is u by g. T1 is equal to u by g. Okay, somewhere it becomes 0. You can apply v is equal to u plus at, and here a is equal to minus g. So you would get this as v is 0, u is u. So you get T1 is equal to u by g. And what about T2? T2 is the time where it is as if projected with. So what is happening after time T1? I'm just writing it down over here. After time T1, it comes down as if it is projected with an initial velocity u, and it has to cover this h, right? So this time is given to you, that is T2, isn't it? Yes. So that being said, so this is going to be, you are going to apply v square is equal to u square plus 2as, or s is equal to ut plus half at square. You can just apply both, but let me think about it. V square is equal to u square plus 2as. That's not going to yield you anything because you don't know u at so v at. So you can apply s is equal to ut plus half at square. And now the thing is, your gravity and the velocity are in the same direction. Okay, so this is going to be u again, and time t2, the time t2, and this is going to be half of g. G is in the same direction, so no minus g anymore, else you write it as minus u minus g minus h. Okay, h is equal to g t2 square. And what is T2? T2 is n times T1, which is nothing but n times u by g. Okay. Yes, that's correct. Okay. And that being said, what is the relationship? Now you got the relationship, and let me write it down. I'm going to just scribble over here, and then we'll write down the final relation over there. This is going to be n into u square by g plus of half into, so g t square, you would again cancel out 1g and you would have it as n u g, right? Yes. N square would appear over here. Okay. N square would appear over here means you need to solve this. You have until here, you can solve the quadratic equation as given in the option. Okay. So you finally have something like this. H 2gh is equal to 2n u square plus n square u square. Okay. Based on this, you can do anything. Okay, this JEE Mains 2014. Yes, based on this, you can do anything that you want, depending upon the kind of equation, what is unknown, what is known, etc., etc., etc. So you have it in terms of h, u, and n. Right? That is all you need to do. All right. So download Unacademy Learning app to attend many such awesome sessions and also to get timely updates on the live classes going on Unacademy. And students, if you are looking for a complete package, an awesome package, the best platform for your JEE preparation, we have that. We have a structured program for your JEE preparation that comes not only with the things that you get everywhere, but also with something more that is going to be like a state of the art technology that puts you in the real-time environment like what you're attending in your exam. And it also comes with the other perks and benefits, a very systematic program where you'd be attending quizzes twice in a week and also test series on regular intervals. So it's going to be a time test practice for you, and comes with all the live quizzes, live test series, and you can learn from your favorite educator, and you pay for one subscription and unlimited access. How do you access this platform? All you need to do is click on that extension bar, choose the plus, and choose your goal as IIT JEE and get the subscription. No, minus would not be there. Why minus would be there? Minus would not be there, right? So if minus is there, that's the wrong answer, because so minus is there, h should also be minus, u would also be minus, g would also be minus. That means everything would cancel out eventually. Okay, minus y direction, minus u direction, minus h. Okay, in your question, what you are saying, you are throwing it vertically upwards with u. Okay, finally when it reaches over here, u is in the minus direction, but g is also in the minus direction, h is also in the minus direction, so there will not be a minus. Okay, there will not be a minus, don't worry about it. And then you will avail the subscription. G should not be minus. G initially would be minus, not finally, right? G initially would be minus because acceleration is like a deceleration acting in the reverse direction, only until it reaches the maximum height. Once it comes down, all are in the same direction. That is wrong. Don't worry about it. Okay. So that being said, this is how you'll get your subscription, guys, and so that is wrong, I guess. So that way, I don't think that is right. Okay, even if you start from initial, this thing ut, but then you can't substitute t is equal to t1. But maybe they did it as like n plus 1. So the other way is like instead of writing it as n into t, what you could have done is you could have wrote it as, so if you are going to take u as positive in that case, then you would have to do like n plus 1. Okay, n plus 2 actually, n plus 2, because n into u by g is equal to t2, t1 is equal to u by g, right? But there would be two such time frames that you need to add to the t1. that t is equal to t2 plus 2t1. Then you can say n plus 2 into u, n plus 2, 2 into n plus u plus, whatever, like, you have n plus 2. I hope you got that point. If there is an n plus 2, yes, it can be minus g. If at all you have the same equation and minus g is given as the correct answer, no, that does not work. I hope you got my point, right? So what I'm saying is, let's say you have something like, the earlier one. So you threw this ball from here, it came down from height h, and you projected with velocity u. Here also it would be u, and we found out the relation, right? Given to you is t1 is equal to u by g. This you can derive. So the time it takes to reach the ground is n times that it takes to reach the highest point. Okay, I'm sorry. So t2 is basically t2 is basically to n times that it takes to reach the highest point of its path. Okay, they are saying this entire t is t. Okay, that is correct. Yes, there would be a 2. Okay, let me tell you. I initially thought I misunderstood the question. I thought, once it reaches this point and it reaches, so what they are saying is the ball is projected up, okay, with velocity u, and it reaches certain height h max, and now the thing is, once it starts coming down, this entire thing, this entire time, this t1, and this t2, all inclusive, is given to you. Okay, so they have told you something that t1 is nothing but u by g, right? How much is total time? Total time is told to you as n is equal to u by g. Since you projected with u in positive direction, you can keep it as s. In even simpler, this is s is equal to ut plus half at square. But now there is a catch. What is the catch? The catch is, I'll tell you. You apply this equation. If this is h, if you take u as positive, you have to keep this as minus h. This is not h max, this is h. Okay. Then this equation is applicable. If you do this, n into u square by g, I'm directly writing it down. This would be minus half g into n square u square by g. If this was not minus, you're going to get a wrong answer. This should be minus. I hope one of your option matches this minus. Minus in h, sign convention, right? So I'm saying this is positive y and this is negative y. So initial velocity is in positive y direction, u is in positive y. Okay, and initial h is minus h. Finally it has to cover this h as well. Okay, it will cover this h max once, then it will start traversing and it will cover minus h max. So h max minus h max reaches 0, something like 0, y, and then it comes back and commutes another minus h. Didn't you get it? Like y minus h? Didn't you get why this is minus h? Is that what you're asking me? Say, okay, let's do it this way, and this might give you better clarity, I guess. If this is 0, this is y is equal to 0. What is this? Y is equal to minus h, isn't it? G is negative, right? Why this is not minus h? This is minus h. If you put it as plus h, then you would get wrong answer, right? You put it as plus h, you will get the wrong answer. Okay. If you put it as plus h, it means you are only trying to assess in the positive y direction how much time it takes to cover that h distance. It may not even cover the plus h distance. Okay, it really depends. Minus g, because g is always like this, negative y direction. Okay, isn't it? It's in the negative y direction. Okay, yes, you can bring the question maybe tomorrow or day after tomorrow, and once you verify this, work it out. If they haven't taken minus h, it is wrong, because it has to, finally the commute has to be in the negative minus h direction. That is what you're trying to calculate. But that being said, students, try to avail this subscription as soon as possible. You get all the perks and the benefits, because you also have access to the best educators and the authors on this platform. This is the only platform across the nation. And guys, only 2 days left for your Unacademy subscription. After that, your prices are going to be hiked from 10th of September. So make sure you enroll early, guys. Enroll early, because it is very important that you don't pay extra bucks for that value platform. Of course, it's worth it. But anyway, make sure you apply Murli live coupon to get instant discount of 10% on any of your purchases. But right now the prices are 32,400 after 10th of September. I mean, from 10th of September, it's going to be hiked by 18,000. So guys, anywhere around 24 hours, 26 hours and odd. So make sure you get it early. And right now the prices are super low. Make sure you take advantage of this. It is anywhere around 1,500 per month, if you have noticed it. And if you apply Murli live coupon, you will get a 10% additional discount even on this purchase. And an ideal program for 11th class students, 12th class students, and 9th class and 10th class students. And if you are planning for long term, if 12th class students, because the prices are super low. And that being said, you can also go for a 12-month subscription, guys, if you are in long term or dropout. But make sure you also avail it early. Right now the prices are anywhere around 2,500 per month. You can get a 10% instant discount by applying Murli Live. So be sure to apply Murli Live to avail the best discount, be it on any of the packages. But I recommend that you go for a 24-month package if you're a 9th, 10th or 11th class, or if you're in 12th class and planning for a dropout. And students in long term and dropout, you may want to go for 12-month subscription, which is going to cost you only 2,500 per month, but you can get a 10% instant discount on your purchase by applying Murli Live coupon. So do not forget to apply the coupon and avail the 10% discount, be it on any of your packages. We have 6,000 plus materials and 1,500 plus courses on IIT JEE Mains and Advanced alone. So make sure you get it early, apply Murli Live coupon, and do it before 10th of September. Hurry up, students. Take care, stay safe, bye bye. And okay, good question. So why minus G? So I got your question. See, if you took it as plus G, then take U as minus, then you can take H as also positive. Sign convention, that is it, right? So it is basically sign convention, nothing else. So if you're asking me if the ball is coming down with G, why minus G? It's basically coordinate axis. It's a good question. Do a thing. Bring up the square in one of the kinematics class. Will be soon starting with 1D motion. We have completed anyway some of the part, but we didn't complete basic 1D motion, things like that. We'll do it during those session. And a good question. Keep updating on queries like this, so that I'm able to explain these kind of concepts also on torque as well. So why minus G? I hope you understood that point. So what is happening over here? So just a moment. So you have asked me if it is coming down with G. G is actually an acceleration, not a deceleration when it is coming down. Yes, you can do it. You can take this to be plus, this to be plus, but at the final point it's going to be 0. You'll invert the axis. But the thing is, you have to move with a single standard set of sign convention. and we generally assume that G is minus G, I mean A is equal to minus G, because it is a negative y direction. You have to apply the sign convention correctly. If let's say I've taken this to be plus G, if I've taken this to be plus G in the initial equation itself, then I'm assuming that it is being accelerated with plus G in the positive y direction. Did you get my point? That means your ball will never come down, right? V will never become 0. V is equal to U plus GT. Your V will never become 0. Your ball will just escape. That's it. Got this point? If you take it as minus G, you get it, right? After some, because your G is initial decelerating. Yes, from here, if you want to take plus G, invert all these signs, but you have to calculate it twice. But rather, you can initially take G negative, U positive, H negative, and get the answer as well. G is never positive. G is negative. Okay. Alright students, take care, stay safe, bye bye. Bring up these questions in your kinematics lectures. Try to stick to the same kind of topic, and see you in the next class. Take care, stay safe, bye bye. See you in the next class students.